Alright, here in this video I'm going to take us through the Chapter 2 review. I'm going to try to speak quickly to keep it short. You can always go back and replay certain segments though as you need. So first part is determine whether the two diagrams represent a function. Explain how you know. This all hinges around the fact that x can't have an affair. So we're looking to make sure that each x value only has one arrow leading from it. It's okay if two things lead to the same y, that's fine. This first diagram, yes, you can see each x value only leads to one output, one y value. This one here though, this 2, is an x value and it leads to two different options. That's what makes it not a function. What this looks like from a visual standpoint to determine if something is a function or not is the vertical line test. So if you see this here, a vertical line is just a line that runs perfectly straight up and down. If it touches your function two times, two or more, not a function. Another vertical line that would also break it would be right here because it would touch the function there and there. It only has to happen once though for it to not be a function. So this example right here is good enough to show us that it is not a function. Alright, what are the domain and range? Remember, domain is all of our x values, y is all of our range values that are possible. This function here, it's got arrows on both ends, which means it's going to forever branch off slowly, kind of up and to the right, and forever down and to the left. This one would actually traverse all x and all y values, which is why the domain looks like this. X is in between negative infinity and infinity, same thing for y. Remember that we don't put lines under the inequalities for infinity. We didn't talk about interval notation, but if you are familiar with this and you want to use it, that's fine. This one here don't have arrows on the end, so we have to talk about where we end. So for x, furthest that I go to the left is -4. All right, right there. I am allowed to be it because it's a solid filled in circle at the end. The furthest to the right that I go is a 3, but since that circle is not filled in, I will not have a line underneath my inequality here. Now the y, although one circle is closed, one circle is open, is allowed to be equal to both -1 and 1 is because it's there for other reasons other than just the dot. You can see that it clearly reaches the height of 1 and -1. Alright, so evaluating functions, that is as simple as taking your x, plugging it in, all the x's you see with what it asks. The left-hand side stays the same, which is why my answer, I still have f of 3. Otherwise, meanwhile, you just evaluate the right-hand side to get your answer. Same thing even with fractions or whatever. Plugging in the -2 for x here and in here. So f of -2, that's kind of given our instructions. It tells us what we plugged in. This tells us what our answer was. They both just happen to be -2 in this case. What's nice about this is that it also tells us that a coordinate point for this would be 3, comma, -7. And that's what function notation is nice for. Alright, next page. See, the surface area of a sphere is a function of the radius of the sphere. Here's the function they gave us. Evaluate the function for a basketball with a radius of 11.5. Just as simple as taking your radius, plugging it in for r, and then evaluating this whole side. Pi as 3.14, you remember from geometry, or using the actual pi button on your calculator, if you know how to do that. Alright, y varies directly with x. Find the missing value. Y equals kx is what it means to have y vary directly with x. Every time you see y varies directly with x, you should be thinking y equals kx. In this case, we plugged in our y, we plugged in our x, and then we found k right here. Now this k is good for all other scenarios using this same equation. So then it said find x when y was 5. So we plugged in 5, and then we used k right here. Now that we know what k is, we were then able to go through and solve for x. So with that, to solve for that x, I'm just getting this out of the way, what we want to do is get x free, which means we need to multiply both sides of the both sides by the reciprocal. And here that is, multiplying both sides by the reciprocal. When we do that, we get these to cancel and the negatives to cancel, leaving us x, and then on the other side, negative 3 times the 5 tells us that our x is negative 15 when y is 5. All right, but it's all about finding that initial k value and then plugging it in into our formula. Write an equation that varies directly using the following point. That's as simple as finding k, setting up your y coordinate, right? 2 is my y coordinate. Setting up my x coordinate is 6. Solving for k by dividing both sides by 6. And we get that 2/3 simplifies to 1/3. Then you just take that and write your generic equation. Y is equal to 1/3 x. All right, the length of an object's shadow varies directly with the height of the object. A 15-foot tree casts a 60-foot shadow. Write a function rule and determine the constant of variation. We plug in the output, which is the taller shadow, the result. We plug in the input of 15. Solve for k. K is 4. Here's our y varies directly with x. That would tell us how tall a shadow would be based upon what x is. And then it says, what's the length of a shadow? What a 7-foot tree cast? Plug in the 7 for x. Our output would be a 28-foot shadow. And then we can go the other way. What height tree would cast a 90-foot long shadow? That's where we plug it in for y, right? Because we know the output, and we're trying to solve for x by dividing both sides by 4. So a 22.5-foot tree would cast that 90-foot shadow. All right. Find the slope and y-intercept of the following line. This equation is in standard form. It's very important we know how to put it into y equals mx plus b by moving our x term, then dividing all by the number with y. Once you sort that math out and simplify, you get this here. And remember, your slope is the value with x, and your y-intercept is 0, comma, the number on the end. Write an equation using the following information. Slope is -4 and the y-intercept is 3. You can think of that as 0, comma 3. Point slope. That's something you want to have back from your notes. The y minus y1 is equal to m times x minus x1. Plug in your coordinates. So on this one, to find slope-intercept, they told us the y-intercept, so I just simply plug in my slope, plug in my y-intercept. Standard form is moving x onto the same side with y. So here's us doing that. I just add 4x to both sides, and there it is. You do want to make sure that your standard form does not have any fractions in it, though. No fractions allowed. Moving ourselves over here. This time they didn't tell us slope or y-intercept, so we use our slope formula of taking y2 minus y1, then x2 minus x1 to find our slope of 2. Set it up into point slope using either coordinate point, right? You can use either coordinate point. Okay, so now this time to find this slope-intercept, what I did is I took one of my equations in point slope, and now I'm going to solve it out, right? I distributed the 2 right here. Then I am trying to solve for y, so I'm going to subtract 2 from both sides to get that y is equal to a 2x plus 4. There it is. Now, standard form is simply just moving the x to the other side. If there would have been any fractions in here, we would have multiplied everything by its denominator to clear it, to make sure there's no fractions in our standard form. Graph the following line below by changing it into slope-intercept form. We solve it for y. Here we have it. I'm looking for a y-intercept of 4. There it is. A slope of -4 over 5. So going down 4 to the right 5. I could also go up 4 to the left 5. And there is our line. Find the x and y-intercept of the line below. This is in standard form. So remember, to find x-intercept, it's always a 0 in the y direction. Plug in 0 for y, solve for x. X is -3. Very similar for y. It's always 0 in the x direction. Plug in 0 for x, solve for y. Y is 6. Plot those two y-intercepts here. Plot the x in the y-intercept. So we have -3, 0, and then we have 6. And then we can connect these with a line to have our standard form graphed. All right. Write an equation given the graph to the right. This has us look for the key components of a linear equation, which is y-intercept and slope. I can see my y-intercept is at a 2. To find slope, I just count between two whole number points. So I use my y-intercept. I notice I had to go down 4 to the right 1. Thus my slope is -4 over 1. So then with that, here's my equation. Y equals -4x plus 2. All right. So this says write any equation, which means I can use point slope or slope intercept for the following. So when it says it wants a line parallel, we should be thinking same slope, right? Parallel has the same slope, but different y-intercept that also passes through this point. So what I could do is I could do this way. We didn't really see this way in class. And it didn't specify that we had to put it in slope-intercept, so I would instead do this. I'd use my same slope because it's parallel, and then I'd use point slope, my y minus y1, my x minus x2, and I would be able to leave it just like that. If you wanted to put it in slope-intercept, you could solve this equation for y, but you don't have to because it said any form will work. All right, then it says line perpendicular, that's opposite reciprocal slope, but y-intercept doesn't matter, except on this one they want us to travel through this point, so we're going to we have to find what that is. So once again, we didn't really talk about how to do it this way. You can follow along if you want. That's just solving for the y-intercept. Or you can just use point slope, which would be opposite reciprocal, right? Opposite reciprocal of -1/3 is a +3, and then do y minus y1, and then x minus x1. You could also solve this out for y equals mx plus b, and you would get the answer right there. But you don't have to. It did not specify what type of equation that you gave. All right, so this is using the calculator. The table shows the percent of people voting age who reported they voted in the presidential election for the following years. Key component, let 1988 be 0, which really means here when we're entering in, this is year 0, and then this would be year 4, right? This would be year, let's see, are these? This will be year 8 here, right? Because it's years past 1988. And then here we would have year 12. So if you were getting different data than me down here, that's probably why. You didn't set 1988 as year 0 and then count the other years as year past, right? Making this year 16. All right, then you have to know how to enter this into your calculator using the stat button, entering it into L1 and L2. Going to stat, pushing to the right, going to linear regression, finding your different values there. So if you don't know how to do all that, this will be something you'll want to ask me in class so I can guide you through that process. The R value that it would give us on our calculator when we did this is a -0.23. That makes it a very weak negative because you need that R value to be closer to -1 to be considered a strong negative. And then it wants us to find the percentage of people who will vote in 2016, which we'll have to figure out how many years past 1988 is that. It's 28. Plug 28 into your equation. Even though our equation has a low R value, it's not going to be a very good estimator. They want us to estimate anyways. And we would find, after we sort through all this, that it would be 55%. All right, so it says interpret the slope from above using the context of the given problem. Our slope was this component of our line right there, the part with x. We have to talk about the context of the problem, though. Yes, it's going down. So according to the equation, each year 0.1% less of the population votes. Notice how we tied it back into the original equation. It's also implying that back in 1988, our initial value of percentage of people who voted was 57.8. That's what we could have said if it asked us about the y-intercept. The y-intercept would be this value on the end, and we could say, hey, in the initial year they started doing this survey, 57.8% of the population voted. All right. For each function, identify the transformations of the parent function using the parent function as x squared. When I look at this, I see we have a negative out in front. All right, this negative out in front tells us that we have an x-axis reflection. Right? This, let's see, what's horizontal shift of 5? This negative 5, remember, if it's inside the parentheses, that affects us opposite. All right, and something else on this one that I didn't have listed is this 2. This 2 causes us to have a vertical stretch. So we have a vertical stretch by a factor of 2. All right, so it's growing twice as fast. This one here, I see a value on the inside with x, so I have to think opposite. The plus would make me want to go to the right. However, this is a horizontal shift to 1.8 units to the left. The number on the outside always tells the truth. So here this plus 2 would be a vertical shift up 2 units. Write an equation for each transformation. Here's our f of x equation. They want a vertical compression. That means I'm going to have to multiply 1/3 by that 6 that's already with the x. And then we need a reflection in the y-axis, which is where the slope switches signs, but the y-intercept stays the same. Remember, a y-axis reflection was where only your x term takes on a negative. So here's what we do. We multiply the 6 by the compression factor to get the 2. And then they wanted a reflection in of the y-axis. So notice how I only put a negative with the 2. So that also means here I need to switch this over. I've accidentally written the wrong thing. All right, this should be still a subtraction sign. All right, because it says y-axis. Y-axis reflection only affects the slope. The y-intercept should stay the same, so it should stay -2 and -2. All right, so a vertical stretch by a factor of 7. That means we're going to multiply that slope that's already in existence by 7. And a vertical translation up 5 units. So I multiplied this 7 by the existing 6 to get 42. And then added on 5 to the initial -2 or -2 to get a new y-intercept of +3. All right, the graph of the function f of x is shown to the right. Make a table of values for f of x and f of x minus 2. So this column of coordinate points here matches up with the f of x, the black equation. When it says f of x minus 2, that means I'm shifting down 2 units, which means my x's will be unaffected. All we're doing is shifting my y values down 2. Notice how all of those are shifting down 2. And so that would tell me the coordinate points of the blue, which is the exact same shape, just shifted all down 2 units. But notice how like this x-coordinate and this x-coordinate is still the same. It's just that its y-coordinate has been shifted down 2 units. Describe the transformations that occurred from f of x to g of x. Here's f of x. Here's g of x. All right, now I would need to distribute that -2 to help get the equation back into the same form. I want to get this back into the same y equals mx plus b to match up with this one, so that's a little tricky. Don't view it as this, because we actually don't know how to handle if there's a 5 with the x also inside the parenthesis. Distribute it out. Get it back into a form we're familiar with. Okay, so now I'm comparing 5x and -10x plus 2, which has me notice my x only has changed signs, so that will reflect across the x-axis because we distributed negative to all. Remember, if we distribute that negative to all, that is an x-axis reflection. We had a vertical stretch by 2, right, because the initial slope was 5x. Now our slope is 10x. That's vertical stretch by 2. And we also had a vertical shift. We shifted up 2 units because of that plus 2 on the end. All right, so explain how to find the vertex of this absolute value. Well, the 3 doesn't affect the vertex. It only affects the slope. For the x-coordinate, I need to think opposite of our -6. So I'm thinking +6 for my x-coordinate. So I'm looking for a +6 for my x-coordinate. And then the number on the outside always tells the truth. So I'm looking for a 6, -7. This 3 on the outside would just tell us that our slope is now 3/1 in both directions. So, without graphing, identify the slope, vertex, axis of symmetry, and the transformations. Our slope is 1 because there's no number out in front. Our vertex, opposite of the -2 for 2. The 3 tells the truth. There it is. Now, axis of symmetry is always just x is equal to the x-coordinate. That is the vertical line. Right, here's an absolute value. The axis of symmetry is always just that vertical line that travels right through the middle that makes it symmetrical, so it's always just x is equal to the x-coordinate of your vertex because it passes through the vertex. Transformations. I got shifted to the right 2. The -2 makes me want to think opposites, but it makes me want to think to the left, but I have to think opposite. So I had a horizontal translation right 2 and a vertical translation up 3. All right, so write the absolute value for the graph below. I need to find my vertex, which is at -2, 0. I need to find my slope, which is an up 2/3. So here's my slope, up 2/3. My x needs to be with the opposite of -2, which is a +2. Notice how we don't have a number on the end here because I did not move up or down anywhere. The vertex naturally starts at 0, 0. All I did was move to the left. I didn't move up or down, thus my y-coordinate is still a 0. All right, graph the two inequalities below. You would want to locate your vertex, right? Opposite of -2 is +2. 3 tells the truth. Plot that vertex. Look at our slope. It's the value out front. It's a 1/3, so I'm going to go up 1 to the right 3 in both directions. It naturally opens up. Axis of symmetry, there's our x is equal to 2. You can see it's that dotted line here that passes right down through the middle. In terms of the inequality, I see a line, so I drew a line, and y is not getting eaten by the inequality, so I'll need to shade below. All right, on this one we had to solve for y, so remember to switch your inequality because we divided by a negative number. Then you got your y-intercept of 1, you got your slope of up 1/2. Inequality is now facing y, so I shade above, and I draw a line because there's a line under my inequality. All right, so 4 is here. Final problem. You have a $25 calling card. Calls made up using Minutes within the United States cost 10 cents a minute, while calls made to U.S. and France are 25 cents per minute. Set up an equation, 10 cents per x, 25 cents for y. All of those combined have to be less than or equal to 25. Find your x-intercept, by plugging in 0 for y. Alright, then we find our y-intercept by plugging in 0 for x. Right, and that tells us we have an x-intercept of 250, y-intercept of 100. Right, here's our 250, here's our 100. It's connected with a line, and I need to shade below. So every whole number combination underneath this line represents a combination of amount of minutes I can spend for both United States and France minutes and still be under my $25 budget.